Good morning and good afternoon, everyone. Welcome back to the Open Buildings Designer live series. This is our ninth live session in this series. I'm Meenakshi, your host for today's session. Quick introduction to Open Buildings Designer for those of you who are joining us for the first time. This is Bentley's BIM tool for the AEC industry. It caters to all disciplines that go into a regular building project, be it architectural, structural, mechanical, plumbing, or electrical design. This was formerly called EcoSim. And if you'd like to try out what you see in the demo today, you can download your 21-day free trial by scanning the QR code in the top right corner of the window. There will be tips and tricks, user case studies along with it to ensure you gain the most during your trial period. Let's start with a quick round of introduction. For the speakers, we have Andrian and Alan demonstrating Open Buildings Designer today. All three of us are based in Singapore. Andrian, I'll let you introduce yourself.
Okay, sorry. Sorry, I got lost there. Okay,
Yeah.
there. Thank you, everyone. Good morning. Yeah. Hello, I'm Andrian Sandoval. Been with Bentley for 5 years now. I'm an architect by profession. Yeah, I'm glad everyone can join in this session, and I hope you can get more information and knowledge. So yeah, let's have a good day. I mean, good time. Sorry. Thank you.
Thanks, Andrian. Alan, do you want to go ahead and introduce yourself?
Sure. So, hi everyone. I'm Ellen. I've been with Bentley for 4 years this year. I mostly work with users on trainings, customized or paid trainings, as well as provide webinars like this. So, I hope you guys have a really great webinar session today.
Yes, great. And that's me. I'm a sales engineer for building and plant software. I've worked in the AC industry for more than a decade. And so we'll also be taking some questions in the end. Please do go ahead and type your questions in the comments section below the video pane. And we also have our email IDs here. Feel free to email us should you have any questions for us. And here's a larger version of the QR code for the software trial. Please scan, and like I mentioned, you will receive assistance over email to use the trial effectively over the next 21 days. And if you're attending this session over LinkedIn Live, do know that the resolution really depends on your bandwidth and quality of your internet connection. So some tips: connect via the Ethernet cable. It will give you the best quality of the connection. Do close down any other applications that use up too much bandwidth. And the best resolution is achieved when you're not multitasking and switching windows while watching the session. Just in case you don't have a good internet connection, the recording will be posted on our YouTube channel. And all our previous sessions are available on the Open Buildings Designer YouTube channel. And let me show the link for that. So that's like all our previous live sessions are posted on the YouTube channel under the live series. And these are all that we've had so far. We've had 2 roundtables, 8 sessions previously. And we will also post the link in the comments later for you to click on. Okay, moving on to our agenda for today. So, BIM, or Building Information Modeling, has been a buzzword for the AEC industry for over a decade now. In some instances, it's mandatory now to use BIM for new projects. There have been a lot of early adapters to BIM, and they have been reaping benefits over the years. But a large percentage are yet to make the shift completely. So, using BIM does need a paradigm shift to the workflow for most architects and engineers. It can be a daunting process. So, through the next couple of sessions that we have, we hope to highlight the benefits and address some of the challenges that may be faced during the migration from CAD to BIM. And here's a quick look at our agenda. So you can see we'll be talking about flexible design and integrated energy simulation, object-oriented modeling, which is the very basis for BIM, data group systems, creating building views, quantitative schedules and reports, and spatial intelligence for facility management, and also interoperability using the IFC format. So let's start with Alan. Alan, over to you for now. Let me share your
Fantastic.
screen here. Is it okay to share the screen now?
Yes.
Do I have your PowerPoint on the screen? Yeah, there you go. Okay.
Right. So, before we get into the topic, let me just give you a slight overview about Bentley as well as Open Buildings Designer. So, what you're seeing right here is a map, I might say, of the different types of solutions that we have. So, depending on the type of projects that you will have different applications that will be used for it. So, if you look in the middle right here, we have Open Buildings Designer as part of the building project. Okay, even though the word says open buildings, it doesn't mean that it's only for building projects. You can use it for a variety of projects, such as your road and rail project, because in open buildings, our components have BIM elements, we have BIM properties, right? So, for example, if you're working on a building project, you can use a combination of open buildings with STAT for structural analysis, or you can use open buildings with Luminati for your visualization. Okay, so it depends on what is your deliverable. Um, what we'll do next is that we'll show you how you can use Open Buildings Designer in your project, as well as compare the differences between using solely CAD for your project as well compared to using open buildings where we have BIM components. All right. So for most of our Bentley products, the basis is Microstation. So Microstation is our power platform. What this means is that we can use these tools to create our modeling, documentation, and visualization deliverables. Okay, so if you do not need BIM components, this is what you typically use, a CAD platform. What has been done is that open buildings, as well as our uh, solutions right here, uses Microstation as the basis, and we add on top of it. So it's CAD plus BIM. All right. So in Open Buildings Designer, let me open it up. Right. So Open Building Designer comes with a few little companion features, added softwares. So it's Open Building Designer standalone, but we also have Open Buildings Generative Components. Right. This is our computational design application. Right. Next is Energy Simulator. Okay, this is part of your installation. Once you install Open Buildings, this is installed automatically. This is if you have to do any analysis for your HVAC, for example, create quantification, and this would be these two factors uh, would be reviewed in the next few slides. All right. Okay. So we call it open, so open buildings, open roads, open rail. It's because we're promoting this open concept, okay? Which means that if you have open buildings, you can still open um, an open roads file, open rail file. It's just that what the properties that you see might be a little bit different, okay? Because they're different platforms. But it's still possible to open it because the file format is DGN. Okay, all right. So moving on, sorry. Okay, moving on. What I would like to show with you. Oh, give me a second. Let me remove this. Okay. So, moving on, what I would like to show you is the difference between Open Buildings Designer and Microstation. Okay. There are some confusion that I've heard in the industry. Um, so we like to explain to you the differences and why you should use one or the other. Right. So again, I'd like to emphasize that Open Buildings has the capabilities to create CAD models. You don't need a separate software to create your CAD models because it's already built in. Okay, so firstly, okay, with Open Buildings Designer, these components that we have are all uh, controlled by the Python family. So the Python family is the sorry, the Python family holds the levels, the rendering, the layers, and more details for that component. Okay, this is different from Microstation or any CAD platform because these CAD elements are typically controlled or grouped by the levels. Okay, so the level name, the colors, the line style, and so on. Okay, so with this extended family and part, it's an added benefit because you have more things that you can control just in one tool. Okay, moving on. When it comes to information management as well as our catalogs, in Open Buildings Designer, we have our data group system. Okay, this data group system comes with definitions such as the type ID of a certain furniture, the wall information, the structural information of that structural element. Okay, so it's intelligent enough to have this type of component, this type of properties, which Microstation components or CAD components do not have. Okay, so CAD elements are the basis, but you build up on it with some data group system. Right, moving on. Um, when it comes to creating your multidisciplinary, you would require Open Buildings Designer, as this information or these components are your architectural models, your structural models, mechanical models, electrical and plumbing, and so on. Right? So these components are discipline specific. These are in the data group system, data group catalog. Okay. Whereas for your CAD elements, right, these are generic. Okay. If you select an element, it won't be able to tell you that, okay, this is a wall. This is a brick wall. This is a structural column. Okay. These would be just generic solids. Right. So with all of these, you can create your drawing production, and there are many benefits if you were to compare your creating drawing production from your Open Buildings element compared to a CAD element. So with all of these details, we'll be sharing with you um, how does it look like in Open Buildings Designer. Okay. Right. Okay, again, make sure that you know the purpose of your model, your deliverable, and that's where you use a different solution. Mhm. Okay, so we'll first start off with creating parametric components. Why we're starting this off is because depending on your deliverable, okay, you might require different outputs. For example, if you're creating something that has it's not finalized yet, where you still have to create multiple design options, you might use generative components. Okay, but if you're just creating for components, you might use just open buildings. Okay, so open buildings versus open buildings generative components. Right. So these generative components, as I mentioned, is our computational design software, which means that um, it's a different workflow to create your models. Okay, so first we'll start off with the basic parametric modeling. Okay, this parametric modeling is a part of the Microstation tools, right? And I'll show you in this video right here. Right. So this component was created using Microstation, using the basic solid tools, the line tools. From here, once we build it up, we can apply constraints as well as variables to make it more parametric. Okay, this is easy to or simple to do in Microstation or Open Buildings Designer CAD tool because these are your typical workflow. Okay, you're doing it directly in your Open Buildings platform. Okay, if you have to change the values, you can still do it under the variables and it would adjust accordingly. So that's how you would test whether it's parametric. Right? So if you're looking at a smaller scale, you can use the built-in Microstation tool to create your CAD models. Okay, but what you're seeing right here, this is just a CAD element. Okay, it does not have any BIM properties such as your door ID, your IFC override, and so on. Okay, these are just basic CAD tools. Okay, how you can build up from this, okay, is by using OpenBuildings Designer Generative Components, okay, the BIM portion of it. So this is a alternative workflow, um, which is right here, okay, which allows you to create design options based on your node types. Okay, we had a separate webinar session on this, which would be very beneficial if you're interested in learning more about generative components. Right. So what you're seeing here is a BIM model. Okay. We can add details to it. This is a building. Okay. It's not just one singular component. If you have to change the sizing, it's easier to be changed in generative components because you can make use of your sliders as well as your variables. All right. If you have to change the shape of your building, that can be done in the log curve. Right. So this gives more flexibility when it comes to modifying your building, right? As compared to the typical workflow. Okay. So as you can see, this serves as our basis for our building. What is in this building is okay, our core as well as our facade, right? So this depends on your deliverable, definitely. If you're creating a smaller model, you can make use of the built-in parametric cell component, parametric cell tool. But when it comes to creating a bigger, large-scale model, okay, it's best to do it in Directive Components. All right. So for the next portion, um, I'll pass it on to Andrea to share a little bit more about how we can use the energy simulator.
Thank you. Thank you, Alan. So, uh, yes. So basically, what Alan showed you are the different, it's one of the way on how architects can conceptualize prior to designing or firming up the design, right? So that is using our parametric schema, which is using generative components. So this is definitely free along with Open Buildings Designer. Now, moving on to our, next part, which is to showcase another tool inside that of open buildings. All right, so again, using so you're not yet modeling anything. We know architects does conceptualize a lot first before even coming up with, but definitely the floor to floor height and what we envision the building will look like is there. Okay, but being wanting to be sustainable, right? That's everybody's question. How can it blend well with the environment and the like? We have, okay, definitely architects are into visualization. That is generally uh, it's a must, right? It needs to look pretty in the photo and stuff like that. So in terms of CAD base, of course, we in Microstation we do have which is one of the CAD tools in Bentley. We can definitely use it for visualization. However, it's very very limited. So we it does support geolocation, but and also we can have the atmospheric settings. We can even show the solar shadows, exposure calculation. However, in terms of standards, right, like the ASHRAE and SIPSE, it won't have that. It's not supported. So you'll have a feel. You'll know where the sun will be and the likes, but how sure are we that it's sustainable enough, right? That's the next question. But visually, of course, you can attain that. So if how do we do that in a CAD environment? So again, in just clicking on one of the workflows, which is visualization, you can adjust the solar path, right? Therefore giving a feel. So even if it's just a block, okay, even if it's just a block, you can do this. All right, so conceptually you're really thinking of where to put the windows, and maybe put some shade on some side and the like. So this gives you a feel of how you're supposed to design, some variables, and put it on your building. Like the east side might need to have more windows, so to speak, or lesser windows because there's too much sun, something like that. But in Open Buildings Designer, right, it gives you more information regarding on how you can really achieve sustainability. All right, so because energy simulator has this dedicated application. All right, it's very very easy to use. In a while I'll be showing you how easy it is. We have, or it can be base or astray subsidy are supported. Okay, it can define heating and cooling system, and it also creates that performance reports. So if your boss wants to actually see, so how did you achieve this, how did you achieve this design, you can just show, okay, this is the report, and the comparison. So that's how definite you'll be able to have those figures. Okay, so how so with that, the exchange of building energy, so having this information intact, building energy, it can have building energy analysis and performance simulation. So it's inside Open Buildings, definitely free. It comes with Open Buildings Designer, and this is the interface of Open Buildings Energy Simulator. So how it's done. All right. So say for example, we choose a metric. So we're gonna input the project location. So we say we're in Asia. Of course we're in Singapore. All right. So just key in the information. It's not so hard. Again, floor to floor, right? How many floors are we looking at? Glazing percentage, we say it's 40%. Targeted area, what does it look like? So you see on the screen here, we only have a block, right? Not even the defined building. Okay, we give it your thermal properties. Again, we can have a go on saying that it's ASRAE 2010. What building type are we looking at? What are the materials? Even the internal condition, you can actually input it in the system. All right, what type of HVAC? Okay, the start day and the end date, okay, of the simulation. All right, so if it's around June for the opening and the like, okay, what does it say? Now for comparison wise, we are gonna have another project. Okay, again, 3 floors with a glazing percentage now of 60%, won't include skylights. All right, we just change some variables, okay, on our material manager. So you see we're changing the window type here. Okay, and say simulation run name is at 60%. Okay, so we have 40 and 60%. Now if we promote this, you'll be able to have your comparison report. So that easy. So what does it say? You can then design or choose between 40 and 60% in terms of how to verify how sustainable the building would be. Very very detailed. I think conceptualizing the building is now easy if you're using this. um yeah, so okay, so moving on, after you conceptualize, of course you conceptualize your building, what is next, right? So now we're moving into, okay, I've already identified what needs to be there, and the like. Now I want to know, um I want to move into the next step, right, which is the designing part. Okay, so I'll give the floor to Alan to really identify our next phase, or to start off with identifying how to go about into moving on to your design stage. Alan?
Okay, so I just wanted to ask Alan, like we were going to talk about object oriented modeling. So how is it basically different from your basic good old 3D modeling? How would you really differentiate between the two? Do you
All
want me to
right.
share the screen, Alan?
Yes, please. Thank you.
There you go. Okay.
All right. So I'll show you three examples. Okay, how and compare it between CAD and BIM. right? So what we'll see first is when it comes to creating our objects, okay, object-oriented modeling, um, there are there is a big significant difference between creating for your CAD versus for your BIM. Firstly, with your CAD modeling, okay, these typically are made out of solids or shapes first. Okay, you have to create a draft of it first, and from there you promote it to create a 3D model. Okay, you'll notice that with this method, okay, there are properties that are not available, which is something necessary for BIM components such as your wall ID, your file rating, and so on. Okay, so we'll see how does that play a part in the next few examples. Right. So firstly, I'll just show you a slight overview of open buildings, how it looks like. Um, in open buildings, there are different workflows. As you can see on your top left-hand corner, these workflows are categorized, is a way to categorize the different tools. Right. So for the first one, which is building design, this is for your architectural and structural modeling. Okay, as you can see here, as well as the relevant tools that comes with it. So same goes with your building system, which is for your MEP. Okay, and the next view is your basic microstation workflows. Okay, so these are your CAD workflows, be it your 2D, your general tools, your 2D and 3D, as well as your visualization. Right, so what I'll show you is how we model it in the basic microstation CAD workflow. Okay, so what you see here is a slight sketch of how I created the model. This is the basis for our CAD slab, our column, as well as our beam. Okay, so using this shape, we can make use of the extrusion. Okay, extrude. If you know what's the detail, what is the specific height, you can place that. But for example, if I do not, I will just extrude what I have here. Okay, so these elements are following a specific level. For example, this is the structural column. That's why it is using this level properties. From here, I can extrude my beam using extrude along. Okay, and if I want to create my slab, I would use the slab tool. Okay, so this is your basic microstation or your CAD modeling. Okay, let's change this to all right. Okay, this is a basic microstation CAD modeling. If we were to look at its properties, you'll notice that it will say that it's a solid. Okay, and same goes for the other components, right? This will be a solid, and you will have some properties. Okay, this is what it's limited to. The most you can get is its volume as well as the surface area. Right, same goes with our slab. This is a slab with some properties. Okay, as well as our beam. Right. If I want to create a wall representation in my CAD platform, I will use a linear solid, maybe 250 by 4500. Right. From here, I can create my walls. Okay, and to change the display, I have to manually change the level so that it's following the correct level. Wall, maybe change the levels. Okay. So this is how it look like represented in OpenBuildings Designer. Okay, you have to manually change or manually add this type of details such as the levels. You can apply materials manually, which is which is usually the basis of when you create your CAD models. This is how your typical workflow. But when it comes to creating BIM components, you'll notice that it's a little bit easier this way because with our BIM components, okay, with our BIM components. If you look at its properties, you'll notice that, okay, it is structural beam, but it's a pro steel component that has been part of the software. Okay, notice that it's a beam concrete and you have its relevant structural quantities. Okay, so compared to the way of creating CAD models, this does provide more details for you to get more information, for you to utilize it further. Okay, you can add more details to it, such as your project details, to make it more intelligent. Which means that if there's any changes to your model, for example, I've extruded this wall, okay, the material still stays the same, the catalog still stays the same. It's just that the difference is the height. Okay, so previously used 4,500, slightly lesser, but now it's 6,000. Okay, and because these are part of the building design BIM tools, all I have to do is that I can place it and it will add in my family and part details, such as the level, the rendering, the simulation, and so on. So it makes it more intelligent so that it's more detailed, have a higher level of detail. Okay, so that is when you compare modeling for your components, okay, your columns, your beams, your slabs. But when it comes to, okay, an added benefit is that these components in our typical open buildings BIM workflow, these forms relationships, they form links between a certain component. What I mean by that is that if you were to compare the CAD workflow, for example, we have this wall example. If we were to move it, you'll notice that uh, why is my window not moving along with it? It's supposed to be part of that wall. It should move together. But in this example, because this is a linear form and this is a window, it's not moving accordingly. Okay, it stops the relationship. Okay, we do have the example of moving this wall right here. Okay, this wall representation, and it moves accordingly. But if we added any details to this wall, it does not have that relationship. Same goes with our ducting example. If we were to move this, okay, this duct, okay, notice that the one at the back, the main ducting, does not move as well. Okay, it moves separately. Even though it's supposed to be one whole component, okay, it moves separately. So this is a vast difference from using the basic BIM tools, because um, if we were to create our windows as well as our ducting, this actually forms relationship. Let me add one small window right here. All right. So I'll just use one that I have here. Okay. So now that I have this window, if I were to move the entire window, what you'll see is that, oh, my window is moving together. It's grouped together. Okay, because the software is able to identify that these two elements have a relationship. That's why it's moved together. Right? If I were to move this wall, same with the cat, this main wall would also adjust accordingly. Right. So the next example with the ducting, if I were to extrude this, it works the same. If I were to move it, okay, right here, okay, you notice that when the ducting moves, the main branch move as well, the main ducting. Okay, it's because with BIM, it's able to identify that these elements are linked. Okay, it doesn't make sense if I were to move this ducting and these do not follow. Right. So when it comes to making changes to your model, when you're working on a BIM environment, okay, this makes the elements more smarter. Okay, okay, and as you can tell, the properties still remain the same. The information still remain the same. Okay, right? If there's any changes to it, the properties will reflect it. Okay, so that is our second example. Okay, for our last example, okay, this is when it comes to checking your model. Okay, you've already placed your models. It looks great, it looks according, but how do we check it? Okay, that is one of the hardest part, I might say, because when it comes to more complex model, if you can't use a certain tool to check your model, okay, what you have to do is you have to manually check. Maybe this has to be changed. This has to create an opening. I think it has to change. Like you're not you have to do it yourself. Okay, this would be quite tedious, especially if you have a really large model. Okay, for example, if these are CAD elements, the software can't tell that, okay, maybe it's meant to be that way, maybe it's not. So that is why you have to do it manually. Okay, you have to create the opening manually, you have to check it manually. um, but what you can use with OpenBuildings Designer is our clash detection tool. Okay, let me show that in a video for the sake of this webinar. Right. So what we can do is that we can make use of the built-in clash detection tool to create a clash or determine whether the architectural model has any clashes with our mechanical model. Okay, what you're seeing is this architectural file. We've brought in our mechanical file, and we'll just do a simple mechanical to architectural clash. Okay, this is called a job, a mechanical architectural job. What we have to do is that we can just reference it in and just drag and drop. Okay, so this means that it's checking between the architectural model as well as the mechanical model against the mechanical model. From here, it will generate a list of the different clashes as well as some added details. Okay, what you'll notice is that, okay, it's even giving you some properties to it. Okay, it will say that, okay, it's between this element and that element. What are the properties for each element? From here, you can change the different display to see, to give you a different idea of, okay, I know it's between these two elements, but in the actual model, how does it look like, right? So we have three different options, whether you want to see the surrounding, whether you just want to see the two clashes, or whether you want to see the entire model. Okay, but when you select the different clashes, it will actually point out or highlight what are the different components that are clashing. Okay, from here you can actually assign who to fix this issue by writing their contact. You can even change the status to assign to new, and you can even go one step further by document it by exporting it, right? Okay, or maybe if you think it's a little bit difficult to share this screenshot, you can export it as an Excel, make all of your comments, and you can pass it to your colleague or your user. Mhm. What's great is that if you able to use this tool, okay, you can use the same job. Okay, you can use the same job, this mechanical architectural job, and run it for a second time. Okay, just have the same setup, just run it again so that it will show that, okay, these are new clashes, these are old clashes, right? So it's a great tool if you're able to use it in the application, because it will save a lot of time as well as productivity, increase your productivity, right? So that is how you create your objects from CAD or from BIM. Okay, there are different benefits to it. It depends on your deliverable. Um, for the BIM approach, it's more intelligent, which will save a lot of time. Mhm.
Okay, thanks, Alan. So now that you've mentioned about object-oriented modeling, what are the libraries for these objects available within Open Buildings Designer? Andrea?
Yes, yes, thank you. Um, All right. So now that we've seen, how related and how what we can make use of in terms of clash detection. So we move on to how what do we have, right, in open buildings, what can we make use of so that we can really do justice with our detailed design. So in terms of having CAD, of course, you'll have your generic definition, that you can apply in the element or in the model, right? However, it's not parametric. Okay, even the reports that you have cannot be used for editing. So what do we mean, or what do we mean by that? Okay, so say for example, in this model, we know it's a door, right? But upon hovering to it, we it's not defined as a door, right? So in CAD, okay, of course, in Microstation, that is, you can attach that you want this opening, or you want it to be a door. Okay, so we say the type would be sliding and give it a number as 101. And then from there, you can query after you attach it, or attach the properties to this geometry, right? So when you query on this, it will now show that it's a sliding door. Okay, it's the ID number is 101. However, if you move on with, or if you see in our BIM software, Open Buildings Designer, of course, we have what we call data group system. So this data group system is based, or it's the library of open buildings. So it's based on discipline. Focus. It gives you parametric properties. All right. So whatever is inside open buildings, you can add more into it. Schedules, which is used for, which will be able to give you reports, can be used for editing as well. And it gives you that automatic drawing rule. Um, so in a G's, it's gonna be have you're gonna be able to edit the geometry and annotation with very, very minimal efforts. So what does this look like? All right, so we have our dataset tools, we have our catalog, which contains the library, okay, the elements, the objects. Definition is what we call what we call our attributes and properties. Family import editor, which is how the object will look like what Alan mentioned in the um, first few slides, or first few sessions that we have. In terms of, if we look at our catalog, so it contains a large, a large number of elements. So we definitely urge for everyone to please feel free to look at it first before you even customize anything. All right. So to save you the time, again, time is very, very important whenever you're doing your work. So it makes you more productive. So just know the library first before, any customization, or, adding more into the library. With that, of course, if you go over, if you say we have this model, okay, just move on to and click the Explorer on your topmost part. Um, Once in, you'll be able to see the items. So, like what we mentioned, in a CAD environment, you need to attach, right? The item, like, okay, this block is a door, this block is a window. However, in a BIM environment, in Open Buildings Designer, whatever library, or whatever discipline you're looking at, you can just safely put, all right, making so it the look, the properties, the definition, since it's parametric, you can just change the geometry to your liking. Looking at our, one of the samples, so say for example, we have a door. Okay, if you want to modify it, again, it's very easy. You can just right click on this, okay, and say modify the door. Right. So with modification, again, um, since this is parametric, I want to change it to maybe 3 meters. Okay. So easily, upon clicking on the screen, any portion on the screen, it's gonna give you a 3 meter door. How are you gonna say that this is 3 meter? Hovering it again, you see the width is 3 meters now. Now, if you want to make use of the reports, again, whatever is in the model, all right, you will have, or you'll know, okay, these are the components that I have in the model. Now I don't want to modify it one by one, so I'm just going to use the report. Okay, so say I click on two of this door, or D3, I want to change it. Okay, you can just give it a go, edit, say I want both of this door to be 3 meters, and instantly it's going to be changed. Right, so very, very easy. So that's how it is for the libraries. That's how the object, the relationship goes for, to make your design, all right, more detailed. Okay, we have a very, very large library, I would say, objects for you to make use of. And so, okay, we go to the next part. Meenakshi.
Okay, so that's it for this one. So yeah, and what about now that we have a 3D model? Of course, we can orbit around, pan, zoom, look at this 3D model. But what about the traditional CAD drawings? How easy is it? Because a larger part of the industry is still, all the consultants is still referring to your 2D drawings, isometric drawings, etc. So how easy is it to generate that from Open Buildings Designer?
Okay, so I'll share with you. Yeah. So as mentioned by Engine, that's where you create your models. That's where you look at the schedules. But when it comes to creating your plans, okay, it still uses the default drawing production tools right here. Okay, drawing production tools. So you can create your floor plans, your section, elevation, details, and so on, right? So in Open Buildings Designer, you're able to um, create your plans in the same file or in separate files. But what I'll be showing you is how, okay, even though they're created in the same or separate files, these are still linked. Okay, these models are still linked. This is through the hyper modeling approach, which means that your 3D model is linked to your drawing, is linked to your sheet model. Okay, so I'll show you how does that look like. So right now what you'll see is our CAD model. Okay, this is using, as you can see here, okay, he's using the basic CAD tools. Okay, a linear form, okay, CAD properties, okay, right. As shown in the previous example, as well as explained by both myself and Andren, um, these components, okay, because they're CAD elements, they do not have certain benefits to it. What I mean by that is that when we look at the plan right here, okay, it does not have any annotations. It does not have any dimensioning, any hatching. Okay. If you want to do that, you will have to do it manually. Okay, because these are CAD elements. The software can't, or the tool can't tell that. Okay, this linear form, is it a wall? Is it meant to be a bridge? Is it meant to be something different? Okay. So if you do have to do annotations, okay, you have to place it manually, such as the wall. This is the brick wall. Okay, so brick wall. Okay, or if this has any dimensioning, right? Okay, and you can add more details to it, such as your hatching. So when it's in your sheet model, okay, you notice that okay, these are the things that I've inputted manually. So this is a more manual approach, more typical approach. Where else if you were to look at the the beam approach of it, or the more intelligent approach of it, what you can see is that okay, these elements already have dimensioning. Okay, it's able to tell that okay, these elements have a certain hatching, has a certain color style. It will be automatically applied to it, right? Because using this new or updated approach, the software is able to tell that, okay, this is a wall. The wall has this hatching, has this line style, and it only shows it for these plans. Okay, so there is control through your family and part. Okay, whereas for CAD is through your levels. Okay, so let me show this again. What I want to show you is that if you were to use this hyper modeling approach where your 3D model is linked to your 2D as well as your sheet model, if there's any changes, okay, to the model, your other relevant files will be updated as well. For example, if there's a slight change to this area of the room, okay, we don't need this door, we just want it to be one continuous corridor. We'll just make the changes, and what you'll see is that once these have been updated, okay, your plans will be automatically updated. Okay, you do not have to redo the hatching, the annotations, they would be adjusted accordingly. All right, so once you do the cleanup, okay, we have to go back to our sheet model, refresh the model, and it will adjust accordingly. Okay, so things that are beneficial when it comes to drawing production is that, okay, again, you have some drawing rules that are applied automatically for you, such as your annotations, the materials, the different hatching will all be applied for you automatically when you create your plans. Okay. If you were to do it in a CAD environment as shown here, okay, notice that these are still very generic looking. You're still missing some added details. Okay. So what I would like to share with you is that, okay, this is a main benefit that comes with using the BIM tools. Uh, I will pass it on to Andren for the next portion.
Yes, thank you. Thank you, Alan. All right, so in terms of your documentation, right? So after, starting off from conceptualization to our, what do you call, modeling, detailing, we then move on to documentation, which is our drawing production. Now, what is next after creating your 2D drawings? Of course, the reports, right? So when we say reports, definitely you can do so in a CAD environment. However, again, there are certain restrictions like it's only file-based templates. Definitely, you can insert it in within the file. You can export it to Excel. However, modification is not supported. So, of course, what do we mean by that? So, as simple as what Alan showed you just now. Okay, so we just go ahead and create the report. So using this tool, all right. So we choose different types of attributes or properties that you want your reports to have in a CAD environment, and the thing is, you will just be placing it onto your 2D. That's how simple it is in a CAD environment. Nothing more, nothing less, basically, right? However, if we go ahead and use a beam software, right, you can, these are just some of the benefits. You can zoom into the elements, you can do a report by count. There's a predefined Excel templates, export and import to Excel can be made, and of course, other, um, you know, um, like text, CSV, and XML can also be made. So how does it look like in a live, project? So say for example, this building, okay, we're just gonna click on data reporting, give it a go on the schedule. All right. So these are the catalogs that are used, or the objects that are used in the building. So if, say, for example, I'm going to create a BIM schedule, which I can also easily configure, all right, or customize. All right, not even configure. So if I want to have a new schedule, I can go ahead, because probably you're gonna have like, this is too much information. I just want to have some, variables on my reports, not all of this. Okay, so you can create a new schedule by just clicking on the properties or definition, okay, as what we call it in open buildings, right? So we have the area, the lengths, and the like. So you can just choose according to whatever you desire into your customized schedule. Now if you miss something, or if you want to take out some of the definition or attributes or properties, you don't want to include that in your reports, that's perfectly fine. You can just go ahead and modify it. Okay, so very very easy, right? So with that, you'll have your customized report. Now with this, again, you can edit all in one go. So say in the mark, I want to have B01. Okay, I want to add all of it. Then it's fine. You can just go ahead and edit. So again, when we say, you can even zoom to this object. So I just want to query on where the location of these beams are. So you can choose through the reports or through your schedule, and click on happily, and all the beams or whatever you query will be there, will be zoomed out. And with that, you can even create your own Excel. All right. So if you want to give it to your stakeholders, to your consultant, provided they don't change, they can add information but never change. Okay. Never change. So this is bi-directional. Okay. So just fill in all the information, necessary information that your consultant, subcontractors may want to put in. So say I change the mark to B1. Okay, save it, and I'm going to push it back to Open Buildings. So once it's pushed back to Open Buildings, definitely whatever is indicated, you know, is going to be shown into that element. So it's going to be incorporated. So if you say you have 2000, that changes was made by the subcontractor, it's going to be embedded in the object. That I think is the most awesome part of this, because you don't need to input it one by one. So this is what we mean by bi-directional. So moving on, of course. So after going through, the reports and the documentation part, now what is next, right? So it's the facilities management part. Yay, the as built and all that. So what are we gonna do next? So Alan.
Yeah, thank you, Anjan. Yes, so we've created our models, we've created our plans, our reporting. So when it comes to documenting our components or using it for facilities management, okay, there are a slight difference in tools. Okay, so for example, if you have this baluster right here, so this is, as you can see, it's a parametric cell. Okay, parametric cell baluster using the default level. Okay, what we can do is that we can use links, okay, or uh, file links, okay. So links such as your files, your key in, or your URL, right? Okay, to add more details to it. So it's easier for them to access this model. Okay, so for example, this baluster, I would like to link it to a certain URL, which is the manufacturer's website. Okay, so I can go and choose, maybe I'll just pick something simple such as Google. Okay, so by doing so, I was like, okay, and it actually provides the link for me right here. So I can open the link, I can edit the link, and I can remove the link. Okay, this is the extent you can go for using it for facilities management. Okay, so just like that, it opens up Google. Right. But if we were to go one step further and use it for the BIM approach, okay, what we can do is that we can export our model into Kobe. Okay, let me show you right here. Okay. Um, so for example, we have our different spaces, okay, different rooms, different areas. We will add our components just like our baluster. But instead of a baluster, I'll add some chairs, some furniture. Okay. I'll add it to our room. Okay. Remember, these are BIM components because these are catalog items. Okay. And because these elements are in these spaces, okay, it's intelligent enough to tell me that, okay, I know that you have these furnitures and is in this office and this kitchen space. Okay, let me link these two together. Okay, the way you can tell is that if you look at the schedules, it would actually identify that, okay, it's in the specific space, right? And if you have to check or find certain elements, you can make use of the Explorer, which will highlight that element. Okay, let me show you right here. Okay, notice that we have in the schedules your furnitures and your spaces. Okay, we can highlight the different elements. And if we were to look under the spaces, okay, second. Okay, you will be able to tell that, okay, these components are in this space, right? You can go one step further by exporting it as Kobe, so that you can use it for your operations and maintenance. Okay. Okay. And with the schedules, as mentioned by Andren, you can export it to Excel, which definitely makes it easier for you to share these documentation. Okay, so what I've shown you is our Kobe, right? Our facilities management. We can use a different method of sharing our model, which is through IFC. Okay, this is where I'll pass it on to Andren, who will share more about IFC.
Thank you. Thank you. Thank you, Alan. So for all right, so for collaboration, right? I believe everybody needs to have, a software that can interoperate and acquire different types of, export it out to other uh, file format. Okay, so if you ask me about how is IFC in a CAD environment, of course you can only read only, right? There's nothing more to it. Just read only. That's it. But if you're gonna use Open Building Designer, our BIM platform, right? It's definitely certified by Building Smart, and the IFC schema 2 by 3 and IFC 4 is there, and it can import and export IFC files, and you can optimize it. All right. So no need third party software to optimize your IFC. It's there. Okay. So that's the most important part, I think. Um, so with that, okay. So just, giving it a go again. We have different types of, files that we can work with. We can export into OBJ, SketchUp, 3ds, RFA. You can import it as well in Open Buildings. Are the usual DWG, and of course the DGN, our main file format. So in IFC, of course, again, as mentioned, this is how your dialog box or of the IFC export looks like. Okay, I'll give you, how it is or in a live environment. So these are the different types of IFC schema. Again, you can map it if there's any customized objects that you're looking into. Of course, you can map it with the corresponding IFC parameters, and you can even assign the floor to floor. So with that, okay, just as simple as this, go ahead to the backstage, go and click IFC. Again, we can optimize it by clicking on the zip IFC file. All right, that's the optimizer. Save it, export, very, very easy. Even you can even put the author, right? And if you open it in your IFC viewer, all right, we're gonna say that we just like to see the architectural discipline. Okay, so again, it's all there, right? Choose the discipline that you would want to look into, and voila, it's whatever information embedded on your original file is there, like how many walls, what's the type, and even the location. All right, it's all there. And as far as the quantities, so whatever you input on your native file is, of course, can be shown in your IFC. So with that being said, I'd just like to cap up the sessions that we can also work with BCF files. Again, we have different types of sessions acquainted with this, so you can go ahead and check it out in our previous session. We also work with iModel, definitely. All right, a detailed one. We have a session for this, so please look for that and check it out. And again, okay, to conclude the session, what are the benefits of Open Building Designer over CAD? Definitely with using the built-in tools that we have, energy simulator and generative components, you can conceptualize and definitely make sure that it's a sustainable design, okay, prior to your designing. Now, going over to productivity, we have object-oriented modeling, and definitely we can assure quality, right? Libraries are there. You can configure it as much as you want, put in definitions or properties. And in terms of your documentation, we have building views, which is associated to your 3D, associated to your 2D, and of course reporting, very easy to use, right? It's even bi-directional, moving it over to Excel and to the 3D in a fly. And during your facilities maintenance, I mean, you can just go ahead and use the spatial intelligence of open buildings for that, and to collaborate and to have that, for you to have the team coordination with your colleagues. We definitely can say that we are interoperable with whatever you're in need of. So yes, go ahead and please upgrade yourselves to BIM. All right, specifically open buildings, please have a go. That concludes my part. I'll hand it over to Minakshi.
Thank you, Andrea, and thanks, Alan. We have a quick question by Muralidharan. It's flashing on the screen. Andrea, do you want to take that on? Can we bring open buildings, open roads, open rail to iModel?
Oh, sorry, I shouted, but I'm on mute. Definitely. Sorry. My answer is definitely.
So that's the whole point of iModel and the open BIM that Bentley is supporting with this open range of software, open buildings, open bridge, open roads, open rail. So you can bring it all together in iModel for sure. It's interoperable, and it's open BIM. So is there? And I think we are running out of time. We will answer more questions, but we will take them on later. We will message you later. So I'm just going to go over very quickly about the resources, learning resources that we have. So the Open Buildings team has put together a very handy resource in our Bentley communities for in our wiki pages. We have a whole, like, it's like an online manual, like, initially earlier we used to have these thick manuals. This is online, it's kept alive, all the content is always up to date and fresh, and look through it. It's got YouTube videos and text, so look through this. This would be the best way to learn open buildings for all different disciplines. If you're an architect or structural engineer, electrical engineer, just look through this. And what else do we have? We also have our webinars every now and then, and all the recordings are saved here for our webinars. On the Virtuosity page, there's a link for that, building design webinars. And we also have a YouTube channel for Open Buildings Designer, and we have fresh content going up, at least maybe 2 to 3 videos going up every week for all the different topics. There are tabs for the live sessions that we have, and generative components and architectural designers. So just browse through that. You will surely find something that you're looking for. Even if you're a user already, like, you can always advance your skills, because there's so much more to in so many ways you can use Open Buildings Designer much better, like using the energy simulation or advanced tools like the computational design tool within it. So moving on, and yeah, we have Bentley communities. If you're facing any issues, just post your question in Bentley communities. You'll get answers from our product experts like Andrea and Alan, or other users. So we have that pretty. It's alive, and all our update information goes on that as well. We have a LinkedIn group now. It's called Inside Open Buildings. So stay tuned for all the updates and the new webinars being announced over there. We have new sessions coming up for everybody who's trying to move from CAD to BIM, or trying to use BIM to its full potential. So stay tuned to that LinkedIn page. And reach out to us. Feel free to reach out to us. These are our email IDs. We have another session coming up on 29th of June that will be mostly for structural design, though, but similar, jumping from CAD to BIM for structural designers. So stay tuned. Thank you, everybody. Thank you for staying with us. And thank you, Alan. Thanks, Andrian. Take care. See you next time. Bye-bye.
Thank you. Bye bye.
Bye.